Hi, I'm Mr. Kangas, and today we're going to be taking a look at Chapter 6, Section 4, Scale Factors, Scale Models and Drawings. And the first thing we need to discuss really is what is a scale model or scale drawing. And a scale model or drawing is a physical model or representation of an object that is either larger or smaller. So it's a larger or short story of it is it's a larger or smaller version of the original. That seeks to maintain relative proportions. So for example, if I'm going to make a smaller version of a building, I'm not just going to do my best to make something that looks kind of like the building and is smaller. I'm going to make sure that if I am building a model of this building, and for example, let's say I'm building the living room. And let's say the living room of this building takes up half the house. When I make my model, that living room will also be taking up half the house. It's not going to be taking up a third of the house or 75% of the house. It's going to be taking up half the house still. And if the garage is connected to the house and the garage is a quarter of the size of the house, then the garage will be a quarter of the size of the house. Things like that. So if you have skylight windows that are, halfway up the roof, like let's say you have a slanted roof and you have a skylight window halfway up the roof, when you make your model, that skylight window will be halfway up the roof. So everything will be proportional in that sense. Everything will correspond to the original. So that when you look at it, you get an actual feeling of what the original would look like. If you look at it and you see the living room takes up half the house in the model, then you can try to picture a house where the living room is half the house. So why do we have scale models and scale drawings? It's for things like, for example, if somebody wants to build a building. Let's say an architect has an idea for a building. He wants to pitch it. He wants to build it.
Benjamin Spring from the main office. Then
he can't build the building first because he has no money and he needs a place to build it. And he can't. So if he can't do that, then how's he going to show off his idea? He can talk about his idea, but a lot of people, when it comes to things like that, they need to see a visual. They want to see what your idea is going to look like. So it's hard for a lot of us to picture an idea just by listening to someone talk. So if you want to pitch your idea for a building to somebody, or for a room, like say you're redecorating a room, if you want to pitch your idea to them, the best way to do that is make a scale model. Make something that looks exactly like the room, that's portable, that's small, that you can bring with you, and then show it off to people and say, this is what it would look like, except just obviously bigger. And then on the flip side of things, you can also, like I said, when you make a scale model, it can be bigger. So when would you want something to become bigger than the original? Let's say you have a TV character that's really popular, there's a parade coming up, and you want to make a float. Well, if you make a float, typically in the floats, you have really big versions of those characters. So you might find maybe an action figure or a stuffed animal or a picture of that character, and you would make a scale model that makes that character a lot bigger. Or for posters, you'd use a scale model that makes it bigger when you are making advertisement posters or when you are just making decorative posters a lot of times. So those are examples of when you might see and use scale model. The primary thing about scale model is when it's like we said before, scale models try to maintain the relative proportions of the original. So like I said, if the living room is half the size of the house in the original, then the living room is going to be half the size of the house in the scale model. And one way that we are able to do that is using something called a scale factor. And most of us have seen scale factors before. But a scale factor might be, for example, that 1 centimeter equals let's say we'll go with 20 feet. Okay, so for every 1 centimeter on the model, that equals 20 feet on the original. You might also see something like 2 centimeters equals 5 miles. So there's all kinds of different scale factors you'll see depending on what it is you're looking at. Obviously, you're not going to see a scale factor that includes miles if you're talking about a building, because buildings typically aren't miles, their dimensions aren't measured in miles. There are a few buildings in the world where you might use miles because they're so tall, but typically that's not going to be the case. You'd probably use something like yards or feet when you're talking about scale model of a building. The other thing about scale factor, though, when you make a scale factor like this, where you're telling us how many feet or miles or yards your centimeters or your inches or whatever represents, you need to do your best to make sure that it is a scale factor that is represented in simplified form. Scale factors are simply ratios. So this right here, this scale factor is actually a 2:5 ratio. For every 2 centimeters I have on the model, I have 5 miles on the original. So that's how it is a ratio. And like we said in previous sections, ratios can be expressed as fractions. So if when you express your scale factor as a fraction, if it is not in simplest form, you need to put it in simplest form. Because scale factor is not going to be useful otherwise. If I tell you that you have a scale factor of 10 centimeters to 20
Rocky,
feet.
Please call extension 302. Rocky 302.
If you have a scale factor of 10 centimeters to 20 feet, that's not nearly as informative as a reduced version of that, because as a fraction, this would be 10 over 20. So a scale factor of 1 centimeter equals 2 feet is much more useful and applicable when we're talking about scale factor. So the important thing here is to, one, recognize what scale factor is. It's a ratio, which can also be expressed as a fraction. And it is telling us how many centimeters, inches, feet, whatever it is, the original has compared to the scale model. So the scale model might have, for every 1 centimeter, the original has 20 feet. Or the scale model may, for every 2 inches in the scale model, maybe the original has 7 feet or 7 yards or 7 whatever we decide it to be, depending on what we're talking about. So what can you do with scale factor? And what are you going to be doing with scale factor in this lesson? You're going to be using it to figure out how big the original is, or how big the scale model should be. And so how would you do that? If you're told that you have a scale factor, for example, of 1 to 5, let's say centimeters to feet. Okay, and so we have a 1 to 5 centimeters, 1 centimeter to 5 foot scale factor, and we are told that our scale model, let's say this is a house, let's say our scale model is 4 centimeters high. Okay, so from the ground up to the roof of this house, the scale model is 4 centimeters high. So this is a really small house. This is a really small scale. And I want to know, how big is the actual house? How tall is the actual house? Well, if the scale factor is 5 feet, okay, and then what we need to do here, we talked about earlier how scale models and objects like to maintain relative proportions. So if you remember correctly, proportions are 2 equal ratios. When you compare the scale factor to the scale factor compares the scale model to the original. So for every 1 centimeter in the scale model, we have 5 feet in the original. So we're doing the same thing over here. We're saying the scale model has 4 centimeters. So how much does the original have? So we're keeping that same 1:5 ratio going over here. So these two fractions or ratios or scale factors should be equal. So what we would do is we would use our proportions equation where we cross multiply. 1x should equal 4 times 5, which is 20. Normally we would have to do something because this would be a one-step equation, but when I did 1 times x, I got 1x. So we already know that x is equal to 20. So the actual house would be 20 feet high. Okay. And I'll do one more example of that. I'm going to change the scale factor to a 2 to 7. And this time we can use inches and yards. Okay. Let's say that we have a scale factor. We have a scale factor of 2 to 7. So there's 2 inches represents 7 yards. Let's say the scale model is 2 inches. Every 2 inches is 7 yards on the original. And this time we know the original. Let's say we're talking about how wide a house is or how wide a room is. This room, let's say it is, we'll go with 10 yards. Okay, this room is 10 yards wide, and we want to know how many inches should our scale be, should our scale room be. So we're going to take the scale factor, we're going to set it equal to x over 10, because our scale factor is 2 inches on top, and so when we make the proportion over here, the x is going to be on top because this represents inches. We don't know how many inches the scale model is wide. So, but what we do know is that for every 2 inches we have 7 yards, and what we do know about the original model is it's 10 yards wide. So if we want the scale model's width, then we're going to have to cross multiply. We get 7x. 2 times 10 is 20. We have a one-step equation that we would solve. We would divide by 7 on both sides, and then x would equal 2 6/7 of an inch. So if you were making a scale model of this room, the width of the room would be 2 6/7 inches wide. So that is how you would tackle scale, finding missing dimensions of either the scale model or the original model if you had the scale factor, using the proportions equation. So this section really isn't going to be much different than 6.3 or 6.2. It's really going to be more of the same, just now we have a way to kind of apply it to a life situation, because scale models and scale factors and scale drawings are all used in the real world. Whereas before you were just working with proportions and equations, which are used in the real world, but there wasn't really any context given. So scale factors is kind of a way to give some context to this skill. So if you did well on 6.3 and 6.2, you should do great on 6.4. So the next video is going to be on 6.5, because there are no more videos for this section. There's only one video, because this is really kind of just more review of what we've already done. So